Good morning, students. So in the last class we have discussed regarding the third type, that is uniform acceleration and retardation motion. So now we'll see the next question, that is our problem number 4. So here you can see, construct a profile of a cam to suit the following specifications. First and foremost, they have given a camshaft diameter 40 mm. So this camshaft diameter is nothing but it is the diameter of the camshaft. So it is not the base circle always, and it is not, definitely it's not the prime circle or offset circle. It's just the camshaft diameter. You can just show that by just drawing that. Next is least radius of the cam. So that is our base circle radius, least radius of the cam. Then you have a diameter of the roller. So when you have a thing like this, you have to fix in your mind that here we are going to use a roller follower. It's not a knife edge or a flat face follower. It is a roller follower. So diameter of the roller is given. So you can find out the prime circle radius by adding the least radius plus half of the diameter of the roller. So that means nothing but 25 plus 25 by 2. So it will be something around 37.5 you will get. Now angle of lift 120 degree is given and angle of fall is given 150 degree. So angle of lift is nothing but it is outward stroke. Lift means it is rising, outward stroke. Then angle of fall is nothing but it is a return stroke, or it is just falling down, that is 150 degree. Then lift of the follower, lift means maximum displacement of the follower, that is nothing but the stroke length, S is equal to 40 mm. Then here one more thing is given, number of passes are 2 of equal intervals between the motions. So you have two motions, that is lift and fall. So number of pauses means nothing but it is the dwell period. Pause means the place where you don't have any rise or fall. So that happens, that is, that period is two times happening between the motion, that means between the lift and the fall. That means first you will have lift, then you have dwell, then you have fall, again you have the dwell. So here angle of lift is 120 degree, angle of fall is 150, so total 270 degree. So total motion rotation of the cam is 360. So from 360 if you subtract 270 you will get 90. So remaining is 90 degree. So this 90 degree should be equally divided in between the motion. That means after lift 120 degree you will have dwell of 45, then you have fall of 150, then again you have again one more dwell of 45. That 90 is divided 2 as 45 plus 45. So like that you can expect the motion or the displacements happening. Now we'll move on to the next part of the question. So you can see here, during lift the motion is SHM. So they have specifically explained here, when it is lift or when it is outward stroke, it is moving by which method? That is our second method, simple harmonic motion. During the fall the motion is uniform acceleration deceleration. That means when it is coming down, that fall, it is happening by UARM. Speed of the camshaft is uniform, line of the stroke of the follower is offset 12.5 from the center of the cam. So when you read the question, you have to keep in your mind the important points. That is, one is the follower is a roller follower. Then in your displacement diagram you have rise as SHM and fall as UARM, and here the follower axis is offset, so you have to draw the offset circle also and draw the tangents to the offset circle and find out the displacement on that. So this is the question. So here they have not asked you to find out the maximum velocity and maximum acceleration, so that is not required. So we will directly move on to the way to draw our displacement diagram. So you can see here, since we have already drawn the displacement diagram for simple harmonic motion and UARM, I am not explaining that in detail. So you can see here, so you know already, first we will draw a horizontal line AX of unknown length. Then we will take the required scale 12, 45, 150 and 45. So if you take 12 centimeter, 4.5 centimeter, then 15 centimeters will be big, so you can either divide everything by 2, so you can get, instead of 12 you can draw 6. Then for instead of 150 you can draw 7.5 centimeter, like that. So 1:2 ratio you can take for scale. Then you can draw the length. So first you can mark that S point, then you can mark T, then you can mark the P. Then there you can divide the AS, this AS into 6 equal halves. Then similarly TP also into 6 equal halves. Then after that we have to draw the semicircle, divide the semicircle into 6 equal halves. Then from there you draw horizontal lines, and from the divisions A's you have to mark small a, b, c, d and e. Then from there you have to join the center C dash. Then from there you can draw the horizontal lines, horizontal to AX. So different horizontal lines like this. So you can see where A is meeting with 1 will be B, 2 meeting with B will be C, then 3 meeting with small c will be capital D, 4 with D will be E, so on, like that. Similarly this side also, the center line 3 dash you can divide into 6 equal halves. Then from the center point you have to join above and below. Then the points, 2 points above the center line join to the above top point, and similarly the 2 points at the bottom you join with the bottom point P. So similarly you can find where 1 dash and the above first line is meeting as J. Then similarly you will get K, L, M and N. Then you have to draw smooth curve starting from A, meeting all the point B, C, D, E, F, G, H, J, K, L, M, N and P. So like that you can draw the smooth curve, and so like this you can finish the diagram. So you can label everything properly, just like this. The lift above YG is lift, then you have a pause, that is nothing but the dwell period, then you have a fall 150 degree, then you have again pause of 45 degree. So this is how we will draw the displacement diagram. Now we will see how to draw the method to draw the cam profile. So you can see the cam profile. So here first of all you have to draw the base circle. Base circle radius is 25 mm. Then you have to draw the 25 mm circle. Then inside that you can draw the offset circle also for 12.5 mm. So you draw the offset circle also. Then you have to draw the vertical tangent from the offset circle, and which is meeting above on the base circle. That point will be A. Then you divide that displacements in the base circle. So you can see, you can AOS is the outward stroke, then SOT will be the pause or it will be the dwell period, then TOP 150 degree will be your outward stroke. So then divide into both outward stroke and fall, you have to divide into 6 equal halves. Then what you have to do is, then you have to draw the prime circle also. Prime circle you know how to draw. 25 plus 25 is the base circle radius plus roller dia by 2. Roller dia is 25 mm by 2 is 12.5. So 25 plus 12.5 is nothing but 37.5 mm. So you can draw that roller diameter and also the prime circle, and on the prime circle you mark the divisions of the outward stroke and return stroke. Then from there join every points 0, 1, 2, 3, 4, 5, 6. All the points you draw the tangents to the offset circle, and on this tangent you have to take the displacement and draw the small circles and join the bases, we'll get the required CAM profile. So this is how we'll complete the problem.